Welcome back to Mechatronics. Last video में we have made this circuit which includes a servo motor which is controlled by a potentiometer powered by a battery, 9-volt battery, and a 705 power regulator. Then we have LCD for printing the potentiometer value and the servo value. Okay, we have discussed all the connections and all the technicalities of how they work in the last video. In this video, in today's video, we're going to code it. Okay, so what we have right now is we have a sample code of LiquidCrystal library, okay, which is for the LCD. So we're just going to delete all of this information because it's distracting. Okay, then I'm going to delete this variable, not needed. Okay, I'm going to delete this hello message, not needed. Also, I'm going to delete all of this, not needed. Okay, so now we have our self open code. Okay, in this code we have included the liquid crystal.h. So what else do we need to include? We need to include one servo library. So let's include the servo library. Include, the command for that is include servo.h. Simple enough, right? Servo.h. See, if you need information about any libraries, any command, anything you don't understand, you just go type that command, okay, and you can find this arduino.cc, Arduino reference. Arduino, the people who made the Arduino has given information to all the, it is open source also, so other people also can add the informations, but it is given by the authentic people, the original people who have made the Arduino. Okay, they have given software support as much as they can. Okay, every syntax, every libraries, you can find information about that in here. So we have what? Include servo in servo S is capital. Then we have to create a servo object. So we will just copy this line, come here, and we will create a servo object. Servo object means what? Like we have created this LCD object, liquid crystal LCD. Okay, we could have just written liquid crystal and in the bracket we should have started the pin naming, but no, we have what we have done, we have written liquid crystal LCD and then we have started the pin connections. Okay, so that's why creating this servo object is important. Why? Because it might be a possibility that you are using many servos in the project. Okay, multiple servos, like you are building a robotic arm, so you might be using 6 or 7 servos. So that's why we need to create the servo object in order to identify each and every servo individually. Okay, ठीक है. Now what is the next step? अब क्या करना है? What is the next step? Next step is to attach the pin you are connecting your servo to, and we do that using the command servo.attach. Not you will use my servo, okay, because that is the name of your servo. So you can do this in, we also don't need this. ठीक है, so हम क्या करेंगे अभी? servo.attach टाइप करना है, तो servo.attach, तो my servo. Why we have written my servo here? Because जैसे कि मैंने बताया अभी कि we might have multiple servos in the project. So my servo.attach tell the servo library that the servo which name is my servo, I want to attach that servo to pin number 9, because in hardware I have attached, suppose I have 3 servo, my servo, your servo, and our servo. Okay, so I have attached my servo to pin number 9, your servo to pin number 10, and our servo to pin number 8. Okay, so similarly I have to tell the servo.attach library likewise that my servo.attach pin number 9, your servo.attach pin number 10, and our servo.attach pin number 8, so that it will attach particular servo to particular pin. Okay, after this, okay, everything is ready, and then we can just write the servo's angle. How to write the servo's angle? Simple, servo.write. Okay, my servo.write. Why? Because again we have to specify which servo you want to write that angle to. Okay, अब एंगल राइट करने का क्या मतलब है? ये एंगल थोड़े LCD पे नहीं दिखेगा ये. दिस एंगल विल बी रिटन टू द सर्वो. मतलब सर्वो अगर समझ लो 0 पे है, सर्वो इफ द सर्वो इज एट 0 एंगल 0 डिग्रीज, देन इट विल जस्ट स्विच टू 90. ओके, दैट्स इट. नो डिफरेंस. ठीक है, तो हम एक वी शुड राइट अ सैम्पल प्रोग्राम टू अंडरस्टैंड वेदर द सर्वो इज, टू चेक वेदर द सर्वो इज वर्किंग और नॉट. ओके, सर्वो के साथ कभी कभार कुछ कुछ प्रॉब्लम्स वी फेस, सो दैट्स then again my servo dot say 60, then delay of 1 second. Okay, done now. So this should start the servo. LCD पे कुछ print नहीं होगा, nothing will be printed on LCD because we have not written any code for that. Just servo will run. It will go to 90, then it will wait for 1 second, go to 60, then it will wait for 1 second, go to 90. Okay, let's see if that is what's happening. See, it's going to 90, then 60, then 90, then 60, then 90, then 60, then 90, then 60. Okay, so it's working. We have perfectly connected it, like, you know, you should check your connections first, right? So we have checked our connection, it is working properly. अब क्या करना है? Now what we have to do? अब हमें क्या करना है? हमें वेरिएबल्स डिक्लेयर करने हैं. क्या क्या वेरिएबल्स डिक्लेयर करेंगे हम? इंट सर्वो पिन. It is important because you might decide tomorrow that you need to attach servo to another pin. Then बार बार आके क्या 9 चेंज करोगे दो जगह? Why do that? Just create a variable, right? Pin number 9. Then we have to create every other every other LCD pins. Okay, वो भी ज़रूरत है. Same reason. RS is for 12. Int en is 11. Int d4 is 5 semicolon. Int yes, visibility is good. d4 is what? d5 is 4. Then we have d6, which is 3. Then at last we have d7, which is 2. Okay, so सारे के सारे we have completely, you know, written the variables for LCD pins and the servo pin. Now what? One more variable for pot pin, potentiometer pin. Pot pin we have connected to A0. Now you don't have to create don't have to write pin mode for any of the LCD pins. Okay, you don't have to write pin mode for any of the servo pins, not needed. It is all done in their library, no need to write anything. Okay, that's one thing. And you do not need to write input for A0 also, because the pin A0 and A5 are for input only. So although it is good to write, you are not needed to write that. Okay, because they are for input only, they cannot produce output. They cannot output high or low, they can just take input. Okay, so what is the next step now? We will create a pot val, right? It is important. Int pot val and comma and servo, not servo, just write angle, right? We need to create the angle of the servo. Now I'm not going to use pen tablet for this. Okay, we have done this multiple times. Okay, just imagine a XY axis. Okay, just imagine a XY axis like this. Okay, or might be flipped in the video like this. Okay, and here 0, 0. Okay, here y axis is the angle and x axis is the potentiometer value, pot value, and y axis is the angle. We want to calculate the angle corresponding to a specific pot value. When we get the potentiometer value, we want to create the corresponding angle, right? So, and what do we have? What the information we have? 0 value means 0 angle. That means a straight line which will pass through the origin. Okay. Then at the end, here, somewhere here, when we get in x we get 1023, in y we will get 180, right? In x we will get 1023, in y we will get 1180. So what will be the slope of this y minus y divided by x? So y is 180 divided by x, which is 1023. Okay, so we get the slope. What is the equation of the line passing through the origin? Y is equals to mx. M means slope. So angle is equals to slope. What was m? 180 divided by 1023 multiplied by x. We got our what we can say value, right? So we will find the decimal value for 180 divided by 1023, which is 1023, which is 0.1759. We will take 6 decimal values, okay, to get an accurate value. So where are we going to write this formula? We're going to write this formula in servo, void dot loop. So angle is equals to 0.1759530 multiplied by what? Pot valve. Y is equals to mx. This is the m. Okay. Now we have declared angle variable and pot valve variable both as integer. So what will happen? Angle will come out to be obviously a decimal value, but as it is declared as a integer, the Arduino will round it off to the nearest integer. Okay, and we will get an integer value for angle, because in the in the command servo dot write, we cannot put anything but integer in the bracket. Okay, because servo cannot move to 1.67 degrees. Okay, it can move to either 1 degree or 2 degrees. Okay, it should be an integer. Okay, ये हो गया खत्म. Now what we have next? We have created the pot valve, pot pin, pot valve. Okay, and the angle also. अब क्या करना है? What we have to do? Let's print a welcome message. LCD dot print. There's no space between dot. LCD dot print. What should we print? Any suggestions? Welcome to our project. Now let's check whether it is more than 16 or less than 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now it is more than 16. So what will happen? It will not fit, or it will overflow, or it will be shifted to the next line. Let's see what will happen. Okay, I'm not going to say anything. Welcome to our project. Welcome to our servo project. Semicolon. Okay, in the void loop, we would first clear the LCD. I told you that there is a command to clear the complete LCD. Whatever you have written, it will be cleared out. The command for clear LCD is, before that we have to give delay here, right? If we do not give delay, it will write welcome to our server project and quickly it will clear, right? Because after void setup completes execution, void loop starts execution. So it will be very quick and we will not be able to read whatever is written there. Just give a 1 second delay. Let's give a 2 second delay. Okay. So LCD dot clear. In clear, you don't give anything in the parenthesis. LCD dot clear is done. Now what we have? We will read the pot valve. So pot valve is equals to analog read pot pin. Analog read pot pin, and then pot valve we have read. Okay, then we will calculate the angle, and then we have to write both of them in the LCD. Now how to write this? And the step is to write what type of first visualize that what you want to write in your LCD. Now I want to write pot valve equals to pot valve, that's the value of the pot valve, then angle is equals to angle value. Okay, now how to do that? First step, I would need to set the cursor. So LCD dot set cursor. Set cursor. Where do I want to set my cursor? 0, comma 0. 0th column and 0th row means the starting index. LCD dot set cursor. I have set my cursor. Then LCD dot print. I want to print a string which will say port val. Okay, then equals to, then space, then string end. Okay, then after this I want to print at the port val value. So I will not give this quotes because that is the variable I am passing to the port, the LCD dot print, right? The variable port val which stores the port val value. Okay, I hope you understood this. This is the string. This will be written like this only. Port val equals to, and this is the actual value of the port val which is stored in the variable port val. Okay. Then in the next line I want to write. So I would set cursor in the next line. How to do that? Column row. So for next line I want to change row to 1. I will not disturb the column part. Again, okay, wait a second. 1. Okay. Then LCD dot print. I want to print angle. So angle equals to, and then I want to print the actual value of angle. LCD dot print angle. Now what will happen? At first iteration, it will read the port val value. It will calculate the corresponding angle. Okay, it will write port val string, port val equals to string. Then it will write the port val value. Okay, when the next time it's executing, what will happen? Suppose I have changed the port val to 0 to 1023. So it will be a overlap of characters. Why? Because port val string will start from 0, 0 only. Okay, and the value will start from which index? 1 2 3 4 5 6 7 8 9. So 10th index. So before the 10th index what was written? 0. यहाँ पे 0 लिखा हुआ था पहले. Now what will be written? 1023. Okay, so it might overlap. Okay, or suppose if I have written 1023 and now it's written 0, so the 023 जो मतलब समझ लो 1023 लिख के आया, ठीक है, तो 1023 जो लिख के आया उसमें मैंने वापस से कम कर दिया पॉट वाल, तो क्या होगा? जो स्टार्टिंग का 1 होगा वहाँ पे तो 0 लिख जाएगा, वहाँ पे तो 0 लिख के आ जाएगा, बट जो 023 लिखा हुआ है वो वहाँ पे रहेगा ही, वो इरेज नहीं होगा. दैट विल नॉट बी इरेज्ड. फॉर दैट व्हाट वी हैव टू डू, वी हैव टू क्लियर आवर एलसीडी, ठीक है, कंटिन्यूसली. सो यहाँ पे हम क्या लिखते हैं? यहाँ पे हम लिखते हैं वी विल गिव अ लिटिल बिट ऑफ डिले, 100 milliseconds suppose, and we have to clear our LCD. ठीक है, ओके, LCD क्लियर ऊपर दिया, ऊपर लिखा हुआ था, वी डोंट नीड टू राइट दिस अगेन. ठीक है, तो LCD क्लियर होगा वापस से, एंड वापस से पॉट वाला एंगल कैलकुलेट होगा. नाउ ये सब चीज़ें तो हो गई. ओके, दिस ऑल थिंग्स आर डन. वी हैव टू राइट द एंगल टू द सर्वो. तो व्हाट इज द कमांड फॉर दैट? माई सर्वो. Why my servo? Because you have named your servo my servo. My servo dot write what angle variable. Just pass the variable directly. Okay. Let's see if there are any errors in the code. Yes, there are errors in the code. What is the error? Something related to comma and put. Error: expected comma or semicolon before int. What? Port val is equals to analog read port pin. Port val comma angle semicolon. Oh, we have not given semicolon here, and it is not allowing me to give any values. Sometimes it hangs. ठीक है, जस्ट इसको रीसेट होने का वेट करते हैं. ठीक है, रीसेट हो गया है. सो व्हाट वाज आवर मिस्टेक. यहाँ पे ज़ीरो के बाद सेमी कोलन लिखना था. ओके, स्टार्ट द सिमुलेशन. ओके, स्टार्ट अगेन द सिमुलेशन. ओके, सो वेलकम टू आवर एस एंड गॉन. क्या हुआ अब ये. सो व्हाट वी हैव लर्न कि अगर इफ़ stop the simulation, if I write it like this, lcd.print without giving the set cursor command or anything. Okay, initially अगर set cursor command नहीं दिया हुआ है, मैं start करूँगा lcd.print, so what will happen, it will start from 0,0, but 0,0 till 16th character it's writing. 16th character कौन सा है हमारा, जो भी है वहाँ तक ये लिख रहा है. उसके बाद वाले कैरेक्टर्स को इग्नोर किया जा रहा है. उसके बाद वाले कैरेक्टर्स न्यू लाइन में नहीं आ रहे हैं. सो उसके लिए हम व्हाट आई हैव टू डू, यहाँ पे सेट कर्सर वाला कमांड लेकर यहाँ पे ऐसे लिखना होगा, सेट कर्सर यहाँ पे 1 एंड अगेन lcd.print करना होगा. Okay, so let's calculate now number of characters printed here. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So till hour we will print in the first line, and servo project we will print in the second line. Okay, it will be welcome to our servo project. Okay, okay, so that is done. Let's see now. Welcome to our server project. Understood how it's done? Why is this blinking, flickering is there? Okay. Sorry for that. ठीक है. So now we can see this is flickering. We don't want this flickering. Flickering कैसे stop करें? पहले हम सब कुछ लिख रहे हैं. ओके, देन डिले आ रहा है एंड देन क्लियर हो जा रहा है, इज़न्ट इट राइट. सो ये डिले को बढ़ा के देखते हैं थोड़ा सा. 1000 इज़ अ बिट मूव है, बस 500 तक बढ़ा के देखते हैं. ये फ्लिकरिंग हो ही रही है. ठीक है, तो डिले हटा देते हैं. लेट्स रिमूव दिस डिले. डिले बेटर था मतलब. ओके, वापस डिले को डाल देते हैं. ओके, आई गेस इन द सिमुलेशन ये फ्लिकरिंग होती रहेगी. डिले से 500 milliamps, 500 milliseconds, not milliamps, sorry. ओके, सो लेट्स इग्नोर दिस. ठीक है, जो एक्चुअल यहाँ पे कैसा है कि रिफ्रेश, मैं बोल रहा हूँ ना कि सिमुलेशन में कैसा होता है कि जो एक्चुअल टाइमिंग होती है, द एक्चुअल टाइमिंग इन द सिमुलेशन इज़ नॉट सेकंड बाय सेकंड लाइक 1 2 3 4. इट गोज मिली सेकंड बाय मिली सेकंड. मीन्स इन रियल 1 सेकंड, इन सिमुलेशन 1 सेकंड इज इक्वल्स टू 100 milliseconds. ठीक है, तो मतलब यहाँ पे अगर 10 सेकंड बीत जाते हैं तब जाके जो 1 सेकंड में जो काम होना होगा रियल टाइम में वो वहाँ पे सिमुलेशन में होगा. ठीक है, कभी कभार ऐसा नहीं होता है, कभी कभार ऐसा होता है. ठीक है, सो दैट्स वाई आई थिंक वी आर सीइंग द फ्लिकरिंग. कि अगर हम लोग स्लो मोशन में देखें एक्चुअल, मतलब एक्चुअल जो हार्डवेयर बनाएंगे उसको अगर हम स्लो मोशन में देखें तो हमें फ्लिकरिंग दिखाई देगी. तो दैट फ्लिकरिंग वी कैन सी इन द सिमुलेशन. ठीक है. let's start the simulation. That is not important. Okay. When you start, you can see that the servo goes like this and then again goes to 0. That happens in real life also. See, now part 1 is 164, angle is 28, so it is moved to 28 degrees. See, now it's 180. So we have completely, see, it's not going to all the way to 180, it's 1-2 degree off. That's what I was talking about. Now it's 0. Okay, if you remove the delay part, okay, it will be much faster and much let's remove the delay part, just give 10 millisecond delay. It will be more real time. Okay, see, it will be, it is more like, it is more respond, what we can say, the response time is much lesser now. Okay, as soon as you move the potentiometer, immediately the servo reacts. Using this project, actually you can make, if you have understood the concept of this project now, using this project you can actually make yourself a robotic arm. You can make different potentiometers. You have different potentiometers to control each arm of the each hinge point, each movement, direction of movement of the robotic arm. Okay, each servo, and you can move your robotic arm using the the potentiometers. Okay, it will be a very fun project to me. Obviously it will be expensive, but it will be fun. Okay, so I hope we have enjoyed the video. Keep learning, keep exploring. I'll see you in the next video. like like my video if you know, if you have learned something from it. Okay, bye bye.